or custodians of the knowledge of these lands. Over to you, Stephen.
Thanks very much, Tracy. I'll just share my screen. Yeah, thanks, Tracy. And as you would have heard there, we're recording this session. So if that's a problem for you, then I suggest you leave the meeting now. So Industry 4.0 opportunities in white certificate schemes. I'll explain, I guess, the two key terms there, Industry 4.0 and white certificate schemes for anyone that's unfamiliar with those terms. My name's Stephen White. I'm the project leader for this project, and Mark Goldsworthy did if you like, the technical work that makes this all possible. You can see there's a bunch of participants in this. The project is sponsored by Race for 2030, so thanks very much to the race crowd that's enabled this to happen. You can see the certificate scheme operators, administrators there who are part of the project, then industry and industry associations that have a strong interest in this area. So just in terms of what we'll cover, I'll give a bit of a project context and scope, then I'll pass to Mark to talk about the technical detail, the M&V analysis, and case studies of using the tool. We do have a tool demo. We'll do it as a video just to corral it into time. We are sort of short for time, and then pass back to me to talk about the EMIS activity. I'll give you that acronym in a moment, and then the so what for this. What does it mean, and what should we do about it? All right, launching right in, project context and scope. What is a white certificate schemes? No, it was not named after me, Stephen White. It is white as opposed to green certificates, and it's particularly for energy efficiency activities. So the way it works is illustrated here. A energy consumer could be a building owner or industrial site or even residential. Goes off to a product supplier and pays for that kit, installs it. And of course, being an energy efficiency product, the building owner would naturally get a reduction in their bills as a result of the reduced energy consumption. The new piece here is that in comes a certificate creator or trader, otherwise known as a accredited certificate provider, ACP in New South Wales, or AP, accredited person in Victoria, who verifies that the equipment was installed and calculates the energy savings, and then certificates are generated that an obligated party is required to collect and then surrender. Normally that obligated party is the energy retailer. So the money from selling those certificates goes back to the building owner, and you have an additional incentive, if you like, to install energy saving equipment. And in a more recent addition to energy savings is peak demand reduction in the peak demand reduction scheme in New South Wales. So that's the white certificate schemes themselves. Just in Victoria, here's a bit of an idea of the sorts of things that get incentivised. You can see business and residential lighting, water heating, in-home displays, shower roses, etc., making up the bulk of the certificates created to 2022. And then there is a small patch on top called other activities. And I guess what we're trying to do here is to target that area and make that easier to do, because typically those bulk ones, the blue and the orange there, they use deemed certificate creation methods. That is, there's a kind of a schedule that says this is an accepted activity and you get this many certificates when you do it. It's all nice and concrete, laid out and easy to do. But when you start looking at more innovative energy saving activities, then you start to need other methodologies, which we'll talk about. Obviously, from a scheme perspective, you kind of want a diversity of products there. You don't want to just incentive one or two products. So there's a strong incentive from a diversity and a risk management perspective and clearly we want to stimulate innovation as well um, and competition there to create the certificates. So our focus, as I say, is more around project-based activities if you were thinking of it in the Victorian scheme perspective. So we came into the project with two Industry 4.0 solutions that had been sort of suggested by the Victorian and New South Wales government. Industry 4.0 is essentially using modern digital technologies for energy efficiency purposes. So the two work packages that we created in this project, each one addresses one of the solutions or opportunities that was given to us. The first one, with a particular focus for the Victorian Energy Upgrade Scheme, was the creation of an activity that is kind of a product class for what is called Energy Management Information Systems. That is the EMIS acronym. The second work package was less to do with individual energy saving technologies or activities, but more to do with the process of actually calculating how many certificates an activity should be able to create. And in both, the EMIS activity itself is a kind of a digital technology solution, and the process that we're creating in Work Package 2 is using digitalization to quickly and cost effectively do the calculations in an automated way. So those are the two work packages that we will talk to. Just a little bit more information on what is this thing called an energy management information system. I love this diagram. It's from Lawrence Berkeley National Labs in the United States, which sort of describes it as a kind of a two-part solution. One part is the digital infrastructure to hoover up all the required data and to warehouse it and make it accessible. And then the second part of the EMIS is then to do something useful with the data, that is provide analytics and perhaps control solutions that actually go about saving energy. So EMIS has both got a data infrastructure component and a productivity apps component. Interestingly enough, it's perhaps a little bit different to a simple technology installation when you actually go about making this happen. And I kind of see it as a bit more like a continuous improvement process, which is probably arguably not as well suited as we might like for the certificate schemes. Starts off at the bottom left there with the EMIS infrastructure component. The consumer will need to do some research to find out what infrastructure they need. Needs to then be installed. That has both a hardware and a software component. But the hardware itself doesn't necessarily generate the savings by itself. Typically, there has to be some sort of business improvement process that gets implemented as well to take the knowledge from the hardware software solution and implement it in the site. Whoops. So once you have your EMIS infrastructure, it's giving you suggestions to rectify a bunch of problems that might be there. You need to go about bringing in contractors to do the rectification works. And once you've actually fixed up all the problems, which are typically discovered in the initial phase of implementation, then you can start to also look at using your digital infrastructure to do things that you otherwise couldn't and drive additional performance. And in terms of your energy savings, this is what it might look like. This particular plot there taken from Buildings Alive, one of the participants in this project, is a wonderful example across 123 large commercial office buildings of digital intervention, that is the EMIS infrastructure and capability going in, and then that sort of continuous improvement process to drive to do actions in a building to deliver the energy savings. And I guess as you'll see during this thing there's this idea of a baseline period. This is prior to anything happening, where sometimes you're consuming a little bit more, sometimes you're consuming a little bit less, but things are trickling along as normal. And then you start taking action, and then you start to see the savings. So, good piece here, large untapped energy savings potential that we're not creating certificates from at the moment, but it's pretty tricky to recognize in the scheme. At what point was the go button hit here where the installation had happened? Is it the end of the baseline region? Or is it after 1 year of rectifying problems, or some other time? Where's your kind of cut-off point for verifying that the project has now been completely implemented? And if the energy savings are bouncing around each year, how do you actually go about calculating those? And it's particularly tricky to deem them up front because you typically can't tell exactly where the problems were that you were rectifying until you've actually got started on the project itself, the classic catch-22 in energy efficiency areas. So the research questions in Work Package 1, what is or isn't an energy management information system? How would we define it in a scheme? What constraints should be placed on eligibility, and how should we calculate the savings and hence the number of certificates that an installation should be worth? So that's Work Package 1. And Work Package 2 then is, as I say, about the calculation of the number of certificates. So there are some existing methods. As I mentioned earlier, the kind of stock standard or most used approach is so-called deemed savings, where it is already specified what installation is. So if you change out to an efficient lighting system, you can look up the factor and you claim it up front. But then there are, for these more complicated solutions, more bespoke ways of doing it, and they typically often use measurement and verification as a way. So in the New South Wales scheme, there's project impact assessment, where you assess how many certificates you think it's going to be, and then you come back after installation, having done some measurement and verification to prove that your impact assessment was good, and you can claim then the certificates for the 10-year period after that. So you do get some level of bringing forward of certificates, which is very attractive for consumers. Another approach, the metered baseline method, is done annually, comparing your bill energy consumption each year against the baseline, and getting an annual amount of certificates. Measurement and verification, I guess, is that process that you have of comparing how much you're consuming now compared with what you would have expected. That's the counterfactual or the baseline, in order to determine how much you've saved. This is established practices internationally. There is the international protocol for M&V, IP, MVP, which is kind of the methodologies that we're drawing on for these performance-based approaches. But unfortunately, it's not being done a lot, and there's a bunch of reasons for that. Lack of awareness, misalignment with business practices. We'll talk to that a little bit later on, things that we discovered in our consultations, and the timing of it. Do people want to wait for a year or more down the track to actually, after the M&V has been done, to get their certificates, or do they want it up front? And if I'm going to measure it and I haven't got any certainty as to how many certificates I'm going to do, it's pretty hard to pull together the business case. There's a whole bunch of that sort of catch-22 type issues. And then we heard a lot about the administrative burden of doing M&V. So the solution, there was a solution developed by the New South Wales government in consultation with participants in the scheme using a human-centred design approach to identify ways in which these M&V processes could be done. And one of the ideas that came out of that human-centered design process in 2021 was this idea of a cloud-based platform with open source code inside it. You upload the metadata, the calculations are done automatically, and certificates can be generated there. So the idea is that the uploaded metadata, you learn the performance or the baseline, and then you look at the energy consumed after the intervention, compare the two to work out the savings. So in conclusion to this sort of introductory piece then, the vision for this M&V tool is that it'll be a digital platform that automates the New South Wales Energy Saving Scheme M&V methods, and it supports the record keeping using the digital tools. And this hopefully provides a simple, low-cost approach for those buildings that fit the eligibility criteria and empower users to track their own energy savings journey. So there's a big theme around automation to make it simple and cost effective. There's a theme around record keeping and the transactive burden there. We know that this is only one optional additional way because not all buildings or sites will be able to get appropriate statistically valid answers from this tool. And there's a big piece which is around empowering users. It's not just sort of get your certificates and then forget about energy efficiency evermore. No, let's go on a journey together is the key. So I'll stop there, and everyone should feel free to be putting questions in the chat function there, which we'll come to at the end, and I'll pass over to Mark then to talk more about the measurement and verification. And I will then come back and talk more about the EMIS activity after that. Over to you, Mark.
Thanks, Stephen. So I've got 3 parts. So I'll talk about the measurement and verification analysis tool development, and then I'll show a video of the online tool, and then I'll come back and talk about some case studies that we did. So as Stephen said, so the aim was to develop a software tool, an automated software tool for doing measurement and verification based on whole of site smart meter data. So you might be forgiven from the name measurement and verification, thinking that we can measure a saving. Of course, you can't directly measure a saving. We measure actual energy use, and then we compare that with a baseline. And the baseline is the counterfactual, and it's the thing that you're referencing your saving to. So there's 2 parts to measurement and verification. So there's the measurement part, but then there's also the modeling of the baseline. Of course, an M&V project involves many stages. So, from planning the project, instrumenting, installing equipment, record keeping, reporting, compliance, and then of course the analysis. So I'm just talking to the analysis part here today. So there are several steps. So we measure the baseline energy use before the intervention's taken place, develop a model for that energy use. Then we perform the intervention and measure the energy use after the intervention, then use the model to estimate the baseline energy use after the intervention, and then finally calculate the savings as the difference between the estimated baseline and the measured actual. So there's a whole bunch of different terminology that gets used there, but the the essence is shown in the figure there. So we have baseline period in blue before the intervention, and then we're measuring the savings compared to that after the intervention. So the primary use case, and the one that we're interested in here, is determining energy savings from equipment upgrades, retrofits, or other interventions. But there are other potential use cases that we could use the same tool for. So, estimating emissions and cost savings, savings across a portfolio of buildings, or even things like tracking regular energy use changes or projecting future changes. So just some other interesting use cases that it's handy to keep in mind. And these plots here on the right are just some examples of the sorts of extra information you can get out of running an M&V analysis with interval or 30-minute metadata. So they're just showing that we can, identify savings that might happen only at certain times of day or at certain temperatures. So the starting assumptions for developing this tool were that not all sites would be suitable. So we know that the tool is not going to work for every building, and not all savings are going to be detectable. So there's going to be some threshold below which the accuracy is not going to be able to detect the savings. We assume that smart meter data is largely trustable. It's used in billing, and there's standards around the equipment and so on, and that we largely we don't have other data from the site. So we have weather data, but not other information or other data streams. Sorry. So the method requirements, we want it to be autonomous, trustable, auditable, very low effort on the part of the user, and fast. So we want it to run quickly in real time, more or less. So we did a literature review focusing specifically on what's called M&V 2.0, or using high resolution metadata to do M&V analysis. There are official guidelines and standards out there. The IP MVP is one of them. There's ASHRAE, and there's other documents as well. Most of them are written for a traditional M&V approach, and there's limited information on uncertainty calculation as well. So there are some academic papers that look into much more complicated M&V models. They tend to often show minimal additional accuracy improvements compared to some of the simpler models. And there's surprisingly been fairly limited attempts to automate the whole process. Some attempts. So we came up with this sort of summary table which divides the M&V analysis process level of automation into data automation and analysis automation. So data automation is, well, how do we get the raw data into the tool in a form that it can be used? And so, basic level would be a person needs to manually upload data and process it, right through to the data automatically flows into the tool. It automatically, links and is interpretable, and the user doesn't need to do anything. And then on the analysis side, a basic level would be you need an M&V expert. You need them to set up and run the model and choose parameters, right through to full automation where anyone can use the tool. It provides full self-diagnosis, and basically can't deliver bad outputs. So we're focusing on the full automation. Some other findings from the literature review. So M&V is related to general load forecasting. So there's a lot of research that's been done on forecasting loads for different applications, and also for baselining in the context of demand response schemes. So there are some similarities there, some things we can draw from, but differences as well. So out of the literature review, there were 4 main challenges that we identified. So the first one was the use of net metering data where there's on-site generation present. So M&V is based on consumption, savings in consumption. And when you have behind the meter generation, that can make it harder to identify whether the savings are due to a reduction in consumption or changes in generation. The second one was handling non-routine events. So there's a plot there on the right, which is just some daily energy use data from a site. You can see it goes up and down a lot. How do you determine from that which, if any, periods are non-routine periods? And then, what do you do once you've decided that it's a non-routine period? The third one there, dealing with difficult to model sites. So some sites just have a lot of variability in the energy use, which is hard to explain with the known with the variables that we have at hand. And finally, quantification of model uncertainty is also a key challenge. So there's a fair few things on this slide. So the approach, we're using NMI meter data that we pull in from the market operator, automatically cleaning and processing the data and applying rules. There's two essential baselining models that are developed. So one is an hourly piecewise weighted multilinear regression, which is similar but not quite the same as the approach used by the Caltrek method in the US. And then there's also a daily model with cooling degree day, heating degree day, and some other variables. Then there's a bunch of automated data and model checks, and I'll mention them in the next slide. And then, of course, the uncertainty calculation, which is a key part of it. Calculation of some additional parameters that relate to the New South Wales rule, energy efficiency scheme rule, and then automated reporting and visualizations. So some of the model checks, so I won't run through them all, but the idea with these checks is to identify sites, automatically identify sites where the models aren't suitable. So because we don't have an expert, we're not relying on an expert to run the process, the analysis needs to know itself when it's not working well. So that's what these automated checks are designed to do. So we validated the method. So the International Efficiency Evaluation Organization has a data set online of 300 and something buildings, commercial buildings in the US. So they have 1 year of 30-minute power and temperature data, and then they have a second year that is hidden. So it's not provided. So what you do is you fit your baselining model to the 1 year of data, and you submit your predictions for the second year, and the website calculates how well your model does. And so this is a comparison of a bunch of all of the models that had submitted their estimates at the time. And essentially, the better models are closer to the zero on the vertical axis and further to the left on the horizontal axis. So our model is doing pretty well compared to some other models that are out there. So I'll run through a video demonstration now of the online portal, which will just show it working in action.
So this is where we start. So at the moment, I'm already logged in. So there would normally be a login part because I've already logged in. We hit get started. And this basically takes us straight to a dashboard where we can add our buildings. Now, here's some I've prepared earlier, which I'll show you in a moment. But assuming that this is the first time I would get onto this platform, the first thing I want to do is actually add my building to my site. So we go through and add our site. So in this case, let's call it building number 206. So we give a site a name. We give a site a postcode. I'll just make this Sydney for this particular building that we're using, and that allows the app to identify the appropriate weather data. So to compare how the building's energy is performing against the local weather profiles. In this case, we're looking at an all-electric building only. So we select our energy retailer, and then we put into our NMI number. So in this case, our NMI number is 31697932006. And then when I hit submit for this, the app actually comes up a whole stack of terms and conditions, which we haven't sorted out, hence the holding text that you can see there. Once I accept the terms and conditions of providing my data to the system, it now goes away and sees if it can actually find that NMI meter and actually access that data. And here we go, and we've got success. So it's found the NMI data, and what it's now is deployed the app onto that data, and it's now generating that particular baseline. So the process varies depending on how big the building is, etc. But generally takes about 20 minutes. So we'll come back to that at the moment, and we see here's our building 206. Oh, baseline is available. Actually, that's very fast. So that was a much better demonstration than the one before. A lot of it comes to how it interfaces with the data. So we've now created this new building, and it's come back with a green tick telling us that that baseline is of high quality, which means that it's pretty much immediately suitable for locking in as a baseline for future energy savings. We can then go and actually investigate that particular baseline. So we've got a couple options. If for whatever reason you need to make adjustments, to say, for example, maybe there was a major shutdown on the building for a period of time for maintenance, or there's some unusual activity, you can actually exclude dates from the baseline calculation. I'll show you that in a moment, but for now, I'm just going to skip that step. And what we end up with is a baseline calculation for that building I've just created. So I'll get Mark to explain what you're looking at here in a moment, Mark Goldsworthy. But we basically have the period for which that baseline was calculated. So that's the data it's used, gives us the total usage of the building for that particular period. And in this particular case, this building 206, what it's telling us is that based on the statistics of this baseline, that the app is capable of detecting energy savings on that building within greater than 0.7%. So any energy savings greater than 0.7%, we can now automatically convert into certificates for this particular building. All right, and in this case, it's a good baseline. If we want to zoom in and look at the detail on any of this, we can zoom in and out on our actual baseline. But I'll get Mark to explain what we're looking at here, because there's a couple of different ways we looked at presenting this, just so you actually know what you're looking at. Mark, you just want to explain that?
Yeah, so we're plotting the difference between the model estimate and the actual estimate. So ideally it would be the chart will be a flat line on 0, so no difference between the model, the baseline model, and the actual. And then the blue line is the daily energy difference between the model and the actual. So it's up and down there. But as long as it's between the two dashed horizontal lines, it's acceptable. So any days that fall outside those horizontal dashed lines, so there's one there around December, that's and what we call an outlier day, so a day where the model and the actual is quite different. So there might be something unusual happening on that day. The black line is the monthly average. So the black line needs to be in the red shaded area. So if, for example, there was a sort of trend over time with the site using more energy over time, which is not allowed if you're trying to establish a baseline, those black lines would sort of wander up outside that red area, and so you would get what we call outlier months. So at the moment, there's a criteria that says you're allowed so many outlier months, I guess, and this model, I think it might have one there on the left. The black line is slightly outside the red region, but essentially it's more or less not trending over time, and there's some sort of above the line and some below the line. So this is a good model.
Those two below the lines look like they're Christmas, aren't they?
Yeah, that could possibly be. So
yeah, so it's 28th, 29th, 29th, and 30th of December. Those are those ones there, yeah.
Yeah, so the model's got public holidays built in, but 28th of December mightn't be a public holiday, but a site might be doing something different on that day. So as James is going to talk about soon, but there is the opportunity to tell the model to exclude or to treat those days differently.
Any questions on this chart while we're on this? Otherwise, I'll just demonstrate the other capability of what's been built. All right, so as Mark mentioned, so this is a good model, so you probably wouldn't need to adjust it. But say, for example, these outliers, which is, as Stephen's mentioned, so we can see this is 28th, 29th, and 30th of December, which sounds like a Christmas shutdown period to me. And maybe that's normal for that building. But say, for example, that was an unusual event that occurred. So maybe there was a major maintenance activity on the site that made the annual usage too low. You can adjust that. So we could go to, for example, adjust my baseline. So I can now go and choose those dates. So 28th, 29th, 30th of December, and hit submit. And now that then resubmits those dates to the application and says rerun that model for me, excluding the dates I've just chosen. So you can pick any of those dates within the period, and it'll continue to then calculate. So you can see now it's recalculating that baseline based on those dates I've just excluded. If we have a look at one where it's come back as needing attention, so we end up with this orange indicator saying there's a baseline, but there's some unusual things going on. So let's select this one. So this is building 201. The first thing the tool does is actually tells you why it's come back with that result, what sort of things are going on. So for example, energy use is consistently lower than expected for 2 months in October and November 2023. In this case, it's also saying energy is higher than expected for 3 months in March to December. So again, we can go and adjust that baseline, but interestingly, in this particular building that's been used here, you'll see the total energy usage is only 34 megawatt hours. So it's actually quite a small building. So therefore, you know, a single piece of equipment could probably actually make this model go all over the place. But you can see here how we've got some of these outliers now outside these months that are much wider than that previous one that we looked at. And again, if we scroll down, we can see some of the issues that the algorithms detected associated with that particular baseline. And again, you can do the same thing, you know, just adjust it, exclude it.
James, the minimum claimable savings 2% here.
Yeah, exactly. Yeah. So this one's, even though it's come back as poor, I think Mark's a very hard marker, I suspect, in designing this algorithm. So even though it's come back as poor, it's sufficiently good enough to detect energy savings greater than 2%. So whether you consider, I don't consider that poor from an energy point of view. Maybe a scientist does. So yeah, there's probably a little bit of work on determining what that grading is. But even then, that's still pretty significant benefit for a building owner, right? That took me 30 seconds to set that up, compared to the 4 days of work required to do that previously. And now I have a baseline that I can measure all future energy savings with and automatically generate certificates for any energy savings that are greater than 2% off that baseline. And that's pretty much all the functionality to date. So it's really about that first part of the user journey. Obviously, the next stages are convert using the baseline, creating an energy efficiency project and putting that into the platform so that it now has a registered project, which then monitors the performance of the building and then automatically converts those energy savings into certificates. Would be the next logical step for this build.
Yeah. So moving on now to a second part. So I'm going to talk about some case studies that we did with some real buildings. So the 4 different case studies. So the first one was looking again at that data set from the International Measurement Verification EVO portal website, so the US commercial buildings. And we're looking there specifically about how many sites actually pass these criteria that we've put into the method. And then a second part, because we don't know if there were any actual interventions in these buildings, we theoretically adjusted the energy use over a certain period to simulate a saving, and then use the models to try and estimate that saving to see if we could get the number back again and to what accuracy. In the second case study, looked at some Australian office buildings where we had net meter data, but also PV generation separately metered. And that meant we could test the effect of having PV generation.
You're going, yeah.
And we could also simulate different
Yeah.
amounts of PV generation just by scaling the actual generation up and down, and so to test the effect of the amount of generation on the model. Then the third case study was again some Australian sites, a different set of Australian sites with direct NMI meter data, and looking at their, why do baseline models fail for some sites. And then finally, an industrial site where there was actually an M&V project, but we were specifically looking at should we be automatically excluding data. So I'll talk to each of those case studies in turn. So the first one, the US commercial buildings, we fit the baseline model to the 12 months of data. And we found that about 40 to 50% of those buildings passed all of the criteria that we've got. So we've got extra criteria that more than is what is in the New South Wales rules. So about 65% of the sites pass the criteria that are in the ESS rule. So the common reasons for not passing were just too much variability in the energy use and too many outlier days. So as I said, we also simulated a 20% energy saving. So not just a flat 20%, but a 20% that varied at certain times of the day and under certain temperatures over 1 month. So normally you would have 1 month before 1 year, sorry, before the intervention and 1 year of data after the intervention. Because we only had 1 year of data, we simulated an intervention for 1 month and then trained the model on the other 11 months and tried to predict the saving for that 12th month. So we knew the answer was a 20% saving for each of these 180 or so buildings. And this table here in the middle is showing the credited energy saving band and the percentage of sites or buildings that were in that band. So we had 72% of the buildings where the estimated credited saving was between 10 and 20%. So remember, the actual saving was 20%, and then another 20% of the sites where it was estimated between 0 and 10%, and then a small number down there at 0. So the credited energy saving is conservative by design, so it tends to underestimate the actual saving. When you aggregate the energy saved across all of those 180 buildings, the actual was 1.98 gigawatt hours. The estimated was very close to that, and then the credited was slightly below. So the credited is conservative, but the errors reduce in aggregate. And those sites that had a more accurate baseline model allowed the full savings to be credited, or much closer to the 20% actual. So the second case study, we had 7 commercial office buildings across New South Wales, 1 year of consumption and generation data separately metered. So we compared fitting the baseline model to the consumption data with fitting the model to the net data, and then changed the amount of generation. So looked at the effect of different amounts of generation. So what we found was, so the greater the amount of PV generation, the more uncertainty it introduces into the estimated consumption baseline. But it was manageable so long as generation was about less than 30% of consumption. If we designed a test to detect the presence of PV generation in net meter data, and that worked well. And we use that to switch between the hourly analysis model and the daily model. So the daily model works better when there's PV generation present. So the third case study, we had 13 different Australian sites. These are not all office buildings, or a range of different use cases. We had the NMI meter data, and several of the sites had multiple NMI meters. So again, it was about 40% of these sites passed all the criteria. And then we were looking specifically at why do sites fail. So these two plots here, the one on the left is the daily energy use of a building that passed all the criteria, and the right one is a fail. So you can see, and sorry, these plots are a variant of the ones you saw in the video, where instead of the daily energy delta, it's the daily energy magnitude, which is a bit easier to understand. So the right one in the early part of the year, daily energy use is up around 600 to 900 kilowatt hours a day, and then later in the year it's hovering around 100, so just above 100. So there's something going on at this site. I don't know what happened. Maybe they installed a large array. Maybe they did something else. But there's a reason why the baseline model should fail for this site. There isn't a steady usage pattern, so you shouldn't be able to calculate a baseline with that data. And so what we found across those 13 sites was, there was always a clear reason for the baseline model to fail one of the criteria, whether it was, large gaps in the data or a trend over time or discontinuities and so forth. So the baseline period needs to be a stable usage pattern. The other thing that came out of this case study was the handling of multiple NMI meters. So there's some complexity there around, what do you do when data from one meter is poor but not other meters, or so on. So the final case study was an industrial site where there was an actual M&V project. But we were looking specifically around the issue of data exclusion. And so is it ever appropriate for the algorithms to automatically exclude data? And so we trialed excluding data using different rules and then comparing the effect on the estimated saving. So this plot here on the right is the normalized saving versus the amount of data excluded. So a normalized saving of 1 means the saving calculated by the model with a certain amount of data excluded was exactly the same as the model with no data excluded. And so as you exclude more data, you move to the right, and then each of the different curves is a different rule for excluding data. So the light blue line with the circles was excluding data at randomly. So we just chose data points at random and just removed them and refit the model and calculated the savings and compared it with the savings from the model with all of the data. And so you can exclude data randomly, and it tends to not change the calculated savings, which is a good thing. If you exclude data preferentially, so you remove the highest energy use data points or the lowest ones, or the ones with the highest model error, for example, the ones that are outliers, then you very quickly change the calculated savings by a significant amount. So the conclusion was the algorithms shouldn't be set up to automatically exclude periods of data. It really does require a physical justification, which requires a human input. The only exception is if there's individual data points where they're clearly bad data points, unphysical or infeasible data point. So the summary, so we've developed this automated M&V analysis approach. As Stephen mentioned, it provides an additional M&V pathway that might work for some sites. We expect on the order of half sites based on the case studies we've done. But a key part of it is for those sites where it doesn't work, we want to fail fast. So you saw in the video, it's a quick process. There's existing meter data there to use. You can determine the model quality and eligibility in real time, and the quantification of the minimum detectable savings even before you've done any interventions or planned an M&V project. So I've talked to the analysis process today, the scope to streamline the broader M&V process as well. I'll hand back to Stephen now.
Thanks, Mark. So just going then into the last section. Sorry, we're running a little short of time, so I'll try and skip through reasonably quickly, focusing in on the EMIS activity and the research we did there. And we did extensive consultation, so just looking at some of the things there. So in terms of the research we did on the EMIS activity, we did a stakeholder mapping to work out who's who in the zoo and what products they're offering. We asked those stakeholders to give us written responses about their products and why they should or shouldn't be included and expectations. We did a bunch of financial analysis, created some what we thought was a reasonable approach to the EMIS activity, and then went out and consulted both with the actual product suppliers themselves, building owners or consumers, energy consumers who would be doing it, and neighbours, assessors. This is just the map that we created of the EMIS products, and there are various ways that it might happen. In the interest of time, I won't go through it, other than to say that there could be three types of EMIS supplier. One is a digital analytics kind of company that offers a software as a service platform, and it probably stands to one side as the technology provider. BMS contractors in buildings could also be skilled practitioners that can provide EMIS consulting services. So in that case, rather than a technology solution, it's a consulting solution. And then the actual hardware providers of controllers and stuff, often they're already cloud connected, and often they already have some sort of built-in algorithms in their controls, which provide some level of service there. And so there's quite an interaction there that you could read about in the report. When we asked for written responses, we got a strong vibe from the providers that installing the technology alone does not solve the problems. And so that goes back to what I said at the beginning. There was a kind of a rectification, taking action on the insights gained from the EMS that needed to happen, and that would probably require some domain expertise. There was a worry about confusion for the customers there, with the number of different permutations and combinations of what an EMIS might be, and certainly a big desire to avoid a race to the bottom of cheap products that don't create effective outcomes. And so there was a sense that there was a need for more guidance material in this area. And we actually asked them to sort of, well, tell us what are the cost of these products, and we actually got quite a strong mismatch, if you like, or differences between different providers and what they thought the cost would be, which probably goes to the heart of what people considered in scope for an EMIS. So in all of this, we identified two phases of the project. And in this plot here, I'm just sort of showing some of our financial modeling there that indicates those two phases. First phase is the implementation phase there. You invest in some hardware, you go negative on your present value. You can see you continue to go negative as you employ people to fix up the problems that are identified. That's in years 1, 2. And then after the problems have been fixed and you start to see the benefits, the present value starts to go up. The blue line there is our modeling without certificates. So these products, on average, based on statistically representative samples of building savings and stuff, should be getting a payback period of around 5 years, and using incentives in the form of VEEKs could bring that down below 3 years, we felt. So as I said, we proposed 2 EMIS activities, one being what's called a foundational EMIS, which is that initial phase right at the beginning where there's investment in kit there. So the scope of work is all around what needs to be installed, but with one additional thing was that there should be set up of some sort of oversight process as part of that scope of works, which goes back to what we heard from our stakeholders there, that it wasn't just the kit that provides the solution. There needs to be a process that goes on alongside that. Had some eligibility constraints there. You know, it should be sufficiently big to be meaningful, and it shouldn't be already par for the course. So some level of additionality that we were creating. And you can see in there the qualified EMIS product. This is sort of, again, reflecting back what we heard, that there was a desire to have a product register of suitable quality products rather than avoid a race to the bottom. I felt the only way to reward this, because the savings hadn't kicked in just through the installation, so therefore some level of deemed savings there in that first phase, and we did the calculations and worked out that around 3% of site energy consumption for 5 years, or about $1 per metre squared, looked like a sensible number. So we wrote up the scope, so quite a detailed specification there of the things that should be done in order to be eligible for that. And rather gratifyingly, a good chunk of that has been adopted by the ABCB in the draft 2025 J9D3 National Construction Code. So you know, that may or may not come out the other end of the line there, but that's certainly been quite influential. So then the second EMIS activity, what we call the advanced activity, is where you actually implement the energy saving activities. Could be fault detection, diagnosis, advanced controls, etc. And to be honest, for us, we're saying it doesn't actually matter that much what it is that you implement there, because what we're asking you to do is to actually measure the savings using the sort of techniques that that Mark's talking about. And so the proof is in the pudding. Have you saved energy? Have you earned the right to create certificates? So 2 activities: foundational EMIS and an advanced EMIS. We took that to industry, M&V consultants, so accredited persons, EMIS providers, facilities managers, and the like. The sort of money up front was deemed to be worth the effort, that sort of $1 per metre squared for the deemed certificates for the foundational EMIS. And you can see that strong desire for a product register to avoid the race to the bottom. And indeed, that whole idea that this scheme points to quality product was certainly something that was very important for industry. And score a 3.8 out of 5 in terms of, yeah, we think that this was something that we would do if we had this in place. We took it to the Sydney Better Buildings Partnership as well, and sort of went through a ranking exercise of what are the most important things for this for you. And interestingly enough, it wasn't the money for the building owners or the consumers of energy. It was more that streamlining of process and fit with neighbours assessors. Ease of record keeping are the things that were deemed to be the most important if this is methodology is going to succeed. So if neighbours assessors are the people that that are the most likely or most desired people, we thought, well, we better go off and talk to neighbours assessors. So we sent out a email to 240 names of neighbours assessors, and 40 odd people came back and said, yep, they'd like to participate, which was quite a nice turnout. And again, really positive response. Yes, it's worth pursuing further. And if it was available, yes, we would use it. So strong endorsement for what we were doing. So in conclusion then, what are we saying needs to happen? What are the next steps for us? Well, you know, now I go into risk of sort of opining on sort of how I feel the world should be, but based on what we've found, what we'd love to see is a journey for energy users that starts off with getting on the platform, check whether you're eligible and can get a statistically appropriate baseline, deploy your energy saving measures, go on your neighbour's rating reduction journey towards zero carbon, start earning your ESCIs and reducing your energy bills, and then start deploying your demand shifting measures. Start tracking your 24/7 carbon emissions. Because this methodology can be done on an hour-by-hour basis, you can match it with grid carbon intensity, and you can start to then think about earning peak reduction certificates and potentially even taking some level of trading exposure on electricity markets. It's kind of a journey, if you like, from that these sorts of tools can potentially allow. But ultimately, what we're trying to do here is there's a whole bunch of stuff that's not getting through the system at the moment. And so how do we reach hard to reach sectors, ones that have perhaps got that are smaller sites, less skills to be able to do this stuff, less informed about the opportunities, such as what you'd see in the low to mid-tier buildings. And based on what we've found, we'd have 3 recommendations here. One is to make this M&V tool available to industry as a government-run or government-authorised methodology. At the end of the day, no one told us that we want more innovation or more competitive or efficient industry. They said that the feeling was that this is a very competitive industry, but the issues that we're facing is we don't know who to trust, we're worried about misleading claims, and we want to reduce compliance risk. So the idea of a government run or authorized method would have strong resonance, is what we heard. Neighbours assessors already in the buildings, already some level of training. If they're going to use, it would be great to help them to be able to run this tool because they're ones who can do the education journey that's required, and they also have the expertise. And the last one there is to sort of get over that catch-22 there, is to actually implement the foundational and advanced EMIS there. And that would help to get people started in a relatively low-risk way on their journey for energy savings. Got much more detail there on how these things address the barriers that we most identified. The top 4 there are on the customer side. The bottom one there, scheme integrity on the scheme administrator's side. And so those 3 solutions I just went through there and why they are important. Don't have time to go into them, but now just to say that there are other use cases. We've focused initially here on just annual energy savings and certificate creation, but it does beg the question, could this be used for the peak demand reduction scheme as well, and for peak or minimum demand? And so that is something, the fact that this can be done on an hour-by-hour basis means that we would assume yes, but we certainly need to do more research on that. And if you're starting to think about peak demand reduction, you may start to think about wholesale demand response mechanism in the electricity industry. And indeed, the PDRS has already put forward the possibility in future of the warm mechanism where certificates would be awarded on the basis of participation in the WDRM. But if you're looking at the electricity industry, you may also start to think about, well, shouldn't flexible assets be sitting on the distributed energy register that AEMO holds as flexible assets that could help with the reliability of the electricity system? And, speculating even further, can advisories be put out if you actually know the baseline? You can help people to know when best to increase or reduce their consumption. And of course, there's a bunch of reporting schemes. I've already mentioned that Neighbours for us is very much entwined in this. Neighbours providing some more baselining information, but also the baselining calculations, potentially helping with new building classes, or even possibly helping with auditing of Neighbours calculations. And final one there, if governments are implementing programs where they are bringing out subsidies for installation of certain classes of equipment, wouldn't it be nice for them to, as they go, to be working out what the impact of the incentives that they're putting out in terms of energy savings, but also demand profile changes as well. So we see that, whilst we've started off with energy saving certificates, there are many, many different applications where these baselining tools could be useful. Still got some work to go. Next steps is, yes, we've done a sort of an MVP GUI, and we showed you the video demo of us with that tool. That goes to the baselining piece. We now need to finish off the workflow, if you like, of once people have actually done their energy savings activity, and then the actual savings calculation. So that needs to be done. We don't currently include gas data. That one's clearly one that is dear to the hearts, particularly in Victoria. Multiple meters, need to improve some of the workflows around that. And we now need to start looking at, how would this be implemented in the scheme? Mark has already put the New South Wales Energy Saving Scheme constraints in there, but there's still plenty of interpretability there that we would need to lock down to make it into a more cookie cutter type tool. More research around M&V for the peak demand reduction scheme, and then pilot case studies, and can we support the doing impact analysis for the business case for implementing this in the schemes. So, I invite anyone that has found this interesting to make contact with Mark and I to discuss what we've been doing and how it may be useful for them. And as I say, we've got a phase 2 of the project that we're putting together the scope for now, and so there's plenty of opportunity to be involved in that. So that's us. I apologise that we've already gone over time. Mark and I are happy to stay online and answer any questions that people have got. And so I can see the chat function there. Mark, whilst I was talking, you've probably had a chance to survey there. Is there any questions that you want to
Yeah,
address?
there was a few questions. I've popped some replies in the chat, but if there's anything that wasn't clear, I can provide more explanation if I can.
Yeah, hi, Chris Rogerson. I just want to thank you guys. It's brilliant what you're putting together. I've been sort of the lone ranger where I'm coming from. I picked this up in Chicago a few years ago through an AIRA conference, and what you guys are doing is fantastic. But just leads me into, I work down the smaller end of the market on air conditioning to reduce the latest inverter. And then your latest inverter air conditioners, and it's very small compared to what you guys are doing. But I believe I've got something, as I say, it's tiny, it reduces the energy, but it also reduces the effect on demand. And it can go from a residential to a small, medium enterprise building to 3 or 4 level building with VRV. And across the board, it's going to have a massive effect on, yes, reducing energy, helping reduce the effect on the grid, but also the demand. Is there any place in what you're doing for this sort of thing?
So what we're talking about here is one method is not to exclude other methods. And so I think it would still be fair to say that the easiest way is if your product or class of product was registered for deemed certificates. So I don't know how it fits in with other classes, others. Whether you've got a class there that could be there, but obviously it's a journey to go down there. But you know, if that's not an option, then yes, this would be an option. And one of the great things about it, it is quite technology agnostic. The actual measurement and verification calculation process. So it's more dependent upon the site, and can the site create a baseline, and less dependent on, you know, what is it that you've actually done under the hood to actually create the savings. So yeah, the products would be available. At the moment, as I say, we haven't done the analysis for the peak demand part of it, or the change of load profile part that you mentioned there, but that's very much part of what we'll be looking at hopefully in the phase 2 project.
So how do I go about deeming? I've been trying to get online. I've tried to contact iPart and a few others, and it's a little bit difficult.
Probably take it offline, and feel free to email me and Mark, and we can talk about that. But,
that's fantastic. Appreciate your comment.
yeah. I see Howard has got a question there. Thank you, Mark. It's been great progress for the industry. How will claiming of certificates be automated? Is this something that the CSIRO can do? Interestingly enough, so we've had a industry reference group, and iPart have been on that, and regularly get pulled up in a friendly way that this is a calculation tool to do the calculation. The tool doesn't create the certificates itself; it just does the calculation, which then needs to go through the regulator to actually do the certificate creation piece. So, in an ideal world, when we get this implemented, I would dream that there would be an API across from this tool into the TESA. That's the iPart certificate creation tool. And so it's and the more kind of locked down a process is, then the easier it is to feel that the integrity of the system is being maintained. But that's not the case at this point. You know, we've been doing the research, and hopefully that will then get implemented by the scheme administrators and the regulators in due course. Joe Flynn, is there confidence finance banks would fund projects based on the model and savings forecast? I can't comment on behalf of the financiers and bankers, but that's one of the good things of the thing. Again, the fact that it would be locked down, and so and if it was enshrined in the rule, then it would kind of have that level of authority as a methodology that would support people having trust, and trust, I think, is a important thing that came through in all our consultation. One's been answered. Yep, we'll provide the slides. Okay, I think Mark's answered most of the questions there. So perhaps we'll go offline. Mark and I will just go through the questions. If there's any that we've missed, well, there's one just popped in. And yeah, feel free to reach out to Mark or myself. Thanks very much, everyone. Have a great Christmas and New Year, and look forward to talking to you in the new year. Cheers.